Hi, welcome to my YouTube channel 3D Multimedia. So under the NLP series, today we'll be looking at term frequency TF and inverse document frequency IDF. So what is term frequency TF? It's a metric used in NLP, that is natural language processing and information retrieval, to measure the importance or relevance of a term or a word within a document. Term frequency equals to number of times word is found in the document by number of words in document. So number of times the word is found in the document means, let us take an example, like in that particular sentence we have a particular word called pencil. So we need to find how many times this word pencil getting repeated in the particular sentence. Okay, so we'll count that, and we will count the number of words in the document. That is nothing but the total number of words in a particular paragraph or a sentence. So we'll take the number of times that particular word appears by the total number of words in a particular sentence. Okay, so now let us start programming. So to start with NLTK, first we have to install NLTK library by using pip install NLTK. Then we will import NLTK. We will also import word underscore tokenize for tokenization process. We will import stop words from nltk.corpus. So we know what is stop words. Those are the words which are available in the English dictionary. So even if you have removed from those words, okay, they will not change the meaning of the particular sentence, right? Okay, so we will import counter from collections to count the number of words in a particular document. Okay, then we will import freq, that is nothing but frequency. DIS is nothing but distribution. So frequency, we will import the frequency distribution from nltk dot probability module, so which computes the frequency distribution of a list of items. It also provides a convenient way to count the occurrences of each unique item in a collection, such as words in a text corpus. Apart from that, the counter is more general purpose and suitable for basic counting tasks across various domains, while frequency distribution is more specialized for text analysis tasks in the context of NLP. Since both are almost, they perform the same task, right? So that's why I have differentiated here. Okay, and then we'll be importing math, since we'll be using logarithm in our inverse document frequency. So I have imported math here. So let us execute the whole line. Okay, so once that is done, we need punkt. Okay, so we need this package since we are doing tokenization, and since we are going to remove stop words, so we need to install this a particular package also. So we'll execute this too. So now I'm going to provide two sentences, and I'm going to store that under the variable like sentences. So I have two sentences here, starting from artificial and ending at data. Okay, in punctuation, and I have separated it with comma. Then I have the starting of the next sentence. Okay, the IoT. So I have given this as a list here, and it's also executed. So once that is done, okay, I'm going to convert this particular text to lowercase. So for that, I'm going to use word underscore tokenize in bracket sentence dot lower for sentence in sentences. So this for loop, it iterates over each sentence because there are two sentences here. So it will go into the first sentence. So it means it will go inside the sentences and it will find out the first sentence, and then that will be converted as into lowercase. Okay, and then it will go to the, once that process is done, it will go to the next sentence, okay, under sentences, and it will convert into lowercase. So this also I have executed it. Okay, now let us print the tokens because we have stored the lowercase and we have stored it under tokens. So I'm just printing it. So now you can see those words which were in the uppercase, right? Those words have been converted into lowercase, like artificial, internet. Okay, so we have printed the tokens. Now we have to flatten the list of tokens. So okay, so what is this flattening? Flattening the list of tokens is necessary because we want to calculate the term frequency for each word across all sentences. Since it's in the type of list, okay, so it will be difficult for us to do this frequency distribution. So we are flattening that. So let us see the result of this. Okay, so here you can see that the list started from here, okay, and then it ended here. That is nothing but the first sentence was tokenized and kept at this particular list, and the second sentence, okay, was tokenized and kept under the next, okay, under this particular list. Okay, so both were a two separate list, right? So that's why here I'm going to use for sublist in tokens for word in sublist. So here I'm considering this two of them as sublist from the token, okay, and then I'm going to uh, convert this particular sublist into a single list. That's why we have executed this. Now you can see here, okay, so now we have starting from the artificial, okay, you can see the list has been opened and ending at the cities, the end of the second sentence. So for that we have done the flattening. So let us now come to the stop words. First we have to set the stop words. There are some basic words in that particular English dictionary, so we have to set that. So I'm just printing it and showing you, okay. So these are the stop words. If they are available in our sentence, we are going to remove that, okay. So for that we'll come to this remove stop words. So here we'll be considering all the tokens. All tokens contains the flattened list, right? Flattened list of our words, okay. So we will take it into consideration. Then so okay, so each word from the list will be compared whether they belong to stop words or not. If they belong to stop words, then they will be removed. If they don't belong to stop words, then they will be added into this empty list, okay. Result.append. So let's print this. So those words which were belonging like is, by, has been removed since they belong to the stop words. So let's now calculate the terms. You can see for that, okay, we are assigning a variable tf equal to empty dictionary, and then we will be finding the length of the result. Here the result is nothing but the removal of stop words, right? So those are stored under the result. So we'll find the length of the result. Then here I have printed total number of tokens. So let us execute this. 31 tokens are there, okay. There are total number of 31 tokens. So once after printing the total number of tokens here, you can see here, let's come back here. So result dot count of word, it means nothing but those words which are repeatedly occurring, right? Those words will be counted, and those count will be divided by the total underscore tokens. So total underscore tokens are nothing but 31. So here I'm just printing this. So we know what is tf.items. Tf.items are nothing but which stores the dictionary values like key pair values, right? So okay, so in that what we are going to do, I'm going to print this. So to see the output, for example, so artificial appears only once in both the sentences, so that one will be divided by the total number of tokens, 31. So you will get this value. Similarly here, let us see any values has been changed. You can see the data. This data has some separate value like 0.064. So let me show you in the sentences. Let us come back here and let us find where do we have data. So we have a data in the first sentence. Apart from that, we also have data in the second sentence. So it appears twice in the particular sentence, okay. So let us take that one. So here, coming back to here, so 2 divided by 31, okay. So I have shown here, okay. So you can see the value here as 0.064. Now go back to this data and just check here. See, you have the same value, right? Yes. Similarly, if there is any other word appears twice or thrice or how many times, that count will be taken and divided by the total number of tokens or words. Okay, so this is how the term frequency is being calculated. So let's now come to the IDF, that is inverse document frequency. It is a statistic used in NLP, natural language processing, and information retrieval to measure the importance of term in a collection of documents. Okay, so we have this formula here. IDF equals to logarithm of 10. That is nothing but log of 10 or log base to 10. We have number of documents divided by number of documents containing the words plus 1. We'll see in detail. IDF also follows the same process, like we will do tokenization, we will remove the stop words, same like what we've done for term frequency. So I'm continuing the part which comes after the removal of stop words. So we have stored those removal of stop words under the variable called result, right? So I'm taking that from there, I'm taking that result and I'm going to find the frequency distribution and I'll be saving it under document frequency, that is DF, under the variable called TF. So first we will find the document frequency, then we'll find the inverse of that. So once that is done, so let us take a empty dictionary and store it under IDF, that is inverse document frequency. That is the variable I have given here. Let us take the length of sentences and store it under, okay, total underscore documents. Let us print that. Then we have df.items. We know what is the output of df.items. That is nothing but it's going to be a dictionary which is going to have the key value pair items. Now let us compute the formula for the IDF. Math dot logarithm to the base 10, that is log to the base 10. Total documents are nothing but the count of 2, right? Because we have 2 sentences. Divided by frequency, how many times that particular word appears in that document or appears in those sentences. So that count will be added with 1. So let's compute this. So here we know the total number of documents I have given us 2. So let us print this IDF for each word. So okay, I'm taking the IDF.items and I'm going to execute this. So it's nothing but the key value pair, right? So now here you can see that the corresponding frequency has been calculated for each of these particular words. So how many times the word appears based on that frequency has been calculated here. So here we have data and which shows that it's in the negative value. Okay, so here the explanation is the value of approximately, that is minus 0.1. So why does it occur? For this IDF frequency, it says that the frequency of the word in the corpus is relatively high compared to the total number of documents because it appears many times, right? So those words which appear many times, okay, and once we calculate the frequency of that along with this log of base 10, you will have the minus value. So similarly, see, you have a dot here, right? That full stop, right? So it also will be appearing in 2 sentences, right? That's why it's also in minus. So here we have computed the value of math separately, like math dot log to the base 10, 2 by 3. 2 by 3 is nothing but 2 is taken as the total number of document as per our formula, right? You can see here total number of documents is nothing but 2, number of documents containing the words. So okay, so here, so nothing but 3 times, that is the word data appears 2 times added with 1, right? So it appears 3. So the answer of this should be in minus, okay, minus 0.176. That is what we have shown it also here. So we have completed term frequency and inverse document frequency. Okay, so here this negative value, it indicates that the word is not very informative or distinctive as it appears in many documents and thus does not contribute much to distinguishing between documents. So if you receive the positive value, then it indicates that the words are very informative. Since we have completed term frequency and inverse document frequency, okay, separately, both of them can also be combined together and we can also do this for the particular sentence. So here I'm going to calculate term frequency along with IDF. For that, what I'm doing, I'm considering this TF word, and I'm also considering IDF word. So from where do we get this? Is nothing but, so let us see for the TF word, term frequency word, we get it from here, from this output. Okay, so the output of this will be taken from here, a TF word, and once we have found this IDF word, right? So both of them will be multiplied here. The word from the each TF will also be considered. Okay, let's execute this. So I'll be printing term frequency separately, inverse document frequency separately, and along with the combining both of them. So this will be my output for all the three term frequency and TF, inverse document frequency IDF, and combination of both of them, term frequency along with IDF. So combining is just nothing but just multiplying both of them and doing the for loop iteration. Okay, so if you have liked this video, don't forget to subscribe my YouTube channel 3D Multimedia. Thank you.